Assalamualaikum warahmatullahi wabarakatuh. We will explain to you about THEVENIN theorem, NORTON theorem, and maximum power transfer. My name is Andre Septian. My assistant code is REN.
Hello, my name is Azizaulia Rahman with assistant code is ZIZ.
I'm Salsa Sabila with the code assistant SAL.
THEVENIN theorem that a circuit can be simplified into Thevenin replacement circuit, which is that Thevenin replacement circuit consists of equivalent voltage source and connected with equivalent resistance that connected in series. This is the electrical circuit in general that we always have met. To find the equivalent voltage source, the first thing that we have to do is to find the terminal AB on the load resistor that we will find, and then cut off the component on the point AB and make into open circuit, and then calculate the voltage on the point AB. To find the equivalent resistance, we should make all the active source into non-active with the note: if we find the current source, we should change it to become open circuit, and if we find the voltage source, we should change it to become short circuit. After all of that, we should calculate the resistance on that circuit. After we have the equivalent voltage source and the equivalent resistance, we should make the Thevenin replacement circuit and then finish.
The Norton theorem states that an electrical circuit can be simplified into a single current source connected in parallel with the equivalent resistance in the circuit itself. How to simplify the circuit using Norton theorem? There are three steps. First, find the Norton current. Second, find the Norton resistance. And the last is create Norton replacement circuit. To find the Norton current, first, specify node A and B as the object in question. So the question is calculate the voltage in R4. Node A and node B is in between R4. To find Norton resistance, must disable all active source on the circuit. Note, voltage is short circuit and current is open circuit. In the circuit, there is just one voltage, so this voltage is must short circuit, and we can calculate the Norton resistance. The last one, create a Norton replacement circuit. This is a Norton replacement circuit to search voltage in R4 parallel the Norton R and R4. And then use Ohm's law, that is voltage equals current times resistance. So you get it, the voltage in R4.
Now I will explain about the maximum power transfer. Maximum power transfer will happen when the value of the load resistance is equal to the source resistance, but installed in series with voltage source or in parallel with the current source. Here, I show an example of solving a circuit using by Thevenin theorem. When we use the circuit completion of the Thevenin theorem, the value of source resistance is the value of equivalent resistance. So, the maximum power transfer will happen when the value of load resistance should be equal to the value of the equivalent resistance. As same as when we use a circuit completion with Norton's theorem. The circuit on the left of the terminal is a Thevenin circuit whose voltage value and source resistance are known. When you want to see how much the power is being transferred to the load in the right of the terminal, you should use the formula that P is equal to I squared multiplied by R. This formula can be proved by explaining the formula as follows. The load power is equal to the load voltage multiplied by the current flowing in the circuit. The load voltage is the current in the circuit multiplied by the load's resistance. It is the same as equal to current squared multiplied by the load resistance. The current in the circuit is equal to the source voltage divided by the source resistance plus the load resistance. So, the load power is equal to the square of the source voltage divided by the total resistance in the circuit multiplied by the load resistance. With assuming that Vs and Rs is constant and PL is a function of RL, the maximum value of PL is equal to the square of Vs divided by Rs plus RL multiplied by RL. The numerator and denominator are squared too. So we can get Vs squared divided by the square of Rs plus RL. So PL is equal to Vs squared multiplied by the power of minus 2 of Rs plus RL multiplied by RL. To find the maximum value of PL, differentiation PL to RL is equal to Vs squared multiplied by the power of minus 2 of Rs plus RL. Subtract by 2 then multiplied by the power of minus 3 of Rs plus RL multiplied by RL. The value of differentiation PL to RL is 0. So that 0 is equal to Vs squared multiplied by 1 divided by the square of Rs plus RL minus 2RL divided to the power of 3 of Rs plus RL. So we can say if 0 is equal to Vs squared multiplied by Rs minus RL divided by the Rs plus Rs cubed. So we can get the value of Rs is equal to RL, or the source resistance is the same as the load resistance for maximum power transfer. Now, this is the final of the video explanation about Module 3 from us. Thank you so much for watching.